Welcome to the webinar on Lean-Agile development. I really appreciate that you are following us. I'm Mario Galassini. I'm a Vice President of EFESO and a Vice President for Innovation specifically, 27 years in the company. And so first of all, for those that don't know EFESO, there are quite a few, because I see that many people are following us across the webinars. In 2 words, we can say we are a company that is really the partner for progression excellence, has 40 years of history, and we are luckily served and are serving important multinational companies and small enterprises. We are really a poor player in operational excellence. We have very loyal customers year after year, and we cover the world, as you can see in the map. We are really committed to giving a high benefit to cost ratio. One of the topics, as I said, that I love very much is this Lean-Agile development, and this fits very well if we want to link with the period and the model we have launched as an answer, a response to the COVID-19. In the module number 4, Reshape, we mentioned Lean-Agile development as one of the answers. And now you might ask, why are you having this webinar at 1? Because originally it was planned for our Chinese clients that usually now it's 7 p.m. in China, and is the after dinner perfect time for let's say leisure activities and cultural activities and these kind of things. Now for us it's 1. So I really encourage you to relax, to have your break. This will not be a heavy webinar, will be 4 interesting examples. And you can make questions, preferably at the end. There will be half an hour of questions and cases where I can present, maybe depending on what you are interested to. I would say this picture I chose on the Panther is perfectly explaining and synthesizing both Lean and Agile, because the Panther is really a good hunter, goes straight to the point in a very fast and agile way. And this is exactly the combination of Lean and Agile. I need to be careful about muting. I can mute otherwise everyone, but okay, thank you. And I would love to say that after the 6 weeks or 7 weeks of quarantine, the Reshape is gone more in this direction, as far as I'm concerned. But that's an advantage of having the camera just on the face. But I would like today to talk about this as the image of the Lean-Agile development. And what is the program for today? The agenda explains what is the context and why now Lean-Agile is a way to answer to the COVID. Number 2, what are the problems in R&D? So what are the issues and losses in R&D, and what can we do with Lean-Agile? An example of the paradigms, so the way to think. We are not talking about really specific solutions today. We can show some examples, but every company, every process is a bit different. But there are some common patterns. They are those Lean-Agile paradigms, and we will apply them to a imaginary simulation of finding the vaccine for COVID-19. I will show you how these paradigms can be applied to reduce the time to market for a vaccine. And then we can explain, I will explain to you what we call the infinite loop in Lean-Agile, so which is the system we need to put in place to guarantee that our flow of projects will be maintained smoothly. And then there will be some case studies and questions. So chapter number 1 is about the context. The context I already explained in our webinar number 4 is first of all showing that the COVID-19 could be the first of important disruptions in our business. So you see, you can have the crisis, which is already showing his teeth, and then the climate change afterwards. And so we need to build a resilient business for that. There is a new context of e-commerce. So Amazon and these kind of services are more and more known and trusted by people that are shut and confined in the house. And also you see that now there are the 3 T's, tracing, treating, tracking. Means one of that will be the app that will help us to understand if we were exposed to the contagion. And Apple and Google, what are they doing? They are competitors where they are trying to find a common technology to have one standard, which is without one standard, one of the two, and half of the maybe of the population will suffer. Please mute. Be careful. Check your mute, your microphone, please. And so we see that Apple and Google are collaborating, which is a way to make open innovation, which is something we can do if we have Lean and Agile in-house. Otherwise, it is really hard. And then we also have the servitization. So what was once, for example, an engine or a machine we're selling now has become something we can sell by the hour. And we can sell on top of that a lot of services of maintenance, for example, remote diagnostic, quality maintenance, and many, many other things. So with those elements, to make it short, there is an opportunity to rethink the purpose of companies and to review the value proposition. To do this, we need to launch projects. So every one of you might be interested. This is not a seminar for just the companies making a lot of projects. It is sufficient to have a big one with thousands of activities which relate with each other, or if you're a company that make a lot of projects, maybe simple, but with the same resources. So there is a lot of interaction in those resources. And nevertheless, there will be the pressure on the CEO. I want to launch those projects and those products, those services, maybe new processes, and I want it tomorrow. And what does it happen? This is an interesting model that I saw that was summarizing my thought. That is, if in the past we had one given life cycle of a product, this is the revenue that could be generated, and this was the development cost. If we start having more and more projects and more products with a shorter cycle time, by definition, the market revenue per product will be less. But overall, the development cost might increase. And this is a trend we can neutralize if we become more lean and agile, and we can do more projects with the same resources. Of course, we will need digital tools. I will show you a very basic one we use to start, so that you can choose then what you want when you want to scale up, and in a shorter time. So without the consequence of this rethinking the purpose is dramatically negative if we are not ready to play with a higher speed. So today, first of all, just to clarify why I've chosen this Lean Agile development linked to the COVID, because this is what exactly gives the strongest answer to the needs of faster go-to-market and optimizing development cost. Of course, if we have another view of our offer, offering in R&D. We see that we include Lean-Agile, digitization, engineering floor management, the Obeya room. But for example, if the product is not the right one, okay, this is not something we can do with Lean-Agile. So we assume that the products and the ideas you have are really answering to a need, and they are smart enough to be manufacturable at a reasonable cost. And they are consistent with the strategy, and your people will understand how to make it. Okay, this is just to give the context. So today we will see how to be excellent in those areas in scope. Good. So now that we have clarified that, let's talk about the issues in R&D, especially in this kind of time to market and cost aspects. So let's, for once, so we have seen the point of view of the CEO that wants a number of projects by tomorrow. Those are the priorities. We can relaunch a business with that. And you have to make it, or you are part anyway of R&D, and it's just a function, but research and development and new product introduction goes across the company. So all of you that are listening are part of that somehow, because you give cost, you give material, and you give strategy, or you give master data. So what is your point of view? Let's sit down with you for a second. So I can show you that there is there's a virtuous circle, there's an increasing stress, not only for the smart working, but also because there is a mechanism that if it is not governed, gives you day by day more work and higher risk to delay projects. Because imagine that we have 4 projects ongoing with some risk of delay, and this is your plan for the day. You have some tasks and some meetings. You do your tasks, some of them are late because you miss an information, you couldn't achieve something, you underestimated a plan. And even those that you consider done, then you discover after evaluating results, some of them are not good, for example, a product test. So you need to replan some of the activities you couldn't finish. Then you go to a meeting, maybe a progress meeting with your boss or with the business, and the business is saying, oh, come on, very good, you're late here. And on top of that, these are the new priorities I'm giving you. So at the end of the day, you find yourself with those amounts of work that was planned, plus extra work to plan new priorities, and then replan those that were not okay and had to be replanned. So the day after, you will have what was planned for tomorrow, plus other meetings, plus part of the replanned activities. This goes up slowly. So we say 5% higher risk day by day, and your frustration, anxiety increases. The point of view of the developer is, I love working in R&D, but I miss not the motivation, I miss a system to protect me. And in fact, it is not really a motivational problem, it is a system problem. We need to solve that. Otherwise, the productivity of R&D will be less and less for unknown causes. So we need to give a name to those problems. And to make it easy, we start with an example with the similarity with the traffic and the cars. So we have one highway where the carriage is the capacity of your funnel. One car, each car is a project, and the driver is the project manager. And the traffic represents the projects in the pipeline. So what are the problems we find? This is after years spent into those environments. I saw that those are very, very common problems. So first of all, the first is the driver has a lower performance because he's doing a lot of things. In this case, he's doing 3 things at least, and the driver cannot go with the right speed on the best speed, and even has the risk even to make an accident. There is the second one, uneven flow projects, where you see that sometimes there are big peaks of traffic, while in other places there is no traffic at all. And there are some points where you have bottlenecks systematically. for example, typically, so this is the seasonality, and this is instead the typical bottleneck resource, the lab or the simulation department, where everybody nowadays wants a simulation because they are not able maybe to take a decision without that. There are also other cases, blockages not prevented. So there was no information about the road. This road was closed, so we need to improvise a detour, which makes us lose time if we are not prepared. And then there is also the case of false positive validation. So we go until the end, and then we discover that there is a mismatch. Of course, that means that the design review did not detect the gaps from specs. That was easy at the beginning of the bridge with the laser. You could align the two parts. Or there is a case where you do a project, and then you go nowhere because the market is not there yet, or is no more there. And there's a case where there is lack of knowledge, so you don't know which decision you can take. Or there is a take, everybody was thinking about that. The project has a problem, and there is a slowdown, there is a blockage, there is an obstacle, bureaucracy. But you see, overall, there is a mix of two sides. The sides of project activities, so maybe the first and the last, but also, this one, but also those related to the traffic, where the driver can do nothing. If even you have the best driver, so the best project and the best plan, you have a Ferrari, you can do nothing in the traffic. So the first lesson, the first message is Lean-Agile development should take care not of optimizing one project, but optimizing the system. Otherwise, it will never work. Because there is a solution. If you take the project of the CEO, it is like the firefighter truck or the fire truck, fast truck or fire truck in this case, in the traffic. What happens? We give the priority to this, and then they will arrive before. Of course, that's for good, for the common good. But the sum of waste in the system is still the same because someone else will slow down. This is not the solution. This is the solution, for example, where there is an emergency, or there can be a solution we found in a customer where we said, okay, we can have 3 projects out of 16 per month. But if we transform every car in a fire truck, we will just have a queue of fire trucks. So that's not the solution. What is instead the solution is to put the flow under control, speed control, and there are smart systems that can really govern the flow. Now, you see, do they eliminate the traffic? Not completely, because you've been queuing in Switzerland, for example, like me, because when there is too much, there is too much. But at least when there is flow, this flow is smooth, and you have less accident, and the overall throughput is much better. So stabilizing speed, eliminate losses. In these roads, you cannot go too fast and you cannot go too slow because you disrupt the flow, which is exactly what we want. So that's the first important similarity I will bring for a while. And then, so what do we do? Shall we use the lean manufacturing? So this is something I find very often, and I really advise you, unless somebody did already in your company, don't stretch lean manufacturing for R&D, because already starting with those loss structure, which is perfect in manufacturing, and is an effort to adapt, can be adapted to R&D, but is not really talking to them. So defects, inventory, waiting, overproduction, transport. Yes, there are people that make marvelous efforts to translate those losses, but the result, I saw many of them, is a disaster. And you lose grip on R&D people because they need to make an effort. So you can categorize everything with this. But if you categorize in losses, those losses should be actionable. So it should give you something more. But if you do an effort to categorize and you don't gain anything, any good information to do something useful for the flow, and then if you make those people, because these are the people in R&D. So I don't know if you know the Big Bang Theory. So they are genius, almost all of them. And they are really tough. If you are not perfectly consistent and sharp, they kill you because they have any capability to discuss, destroy, to follow a logical path, to do really things in their mind that normal people cannot do. So don't mix a simple model for production with these kind of people. You need a better system. And the better system, of course, is what I present. This belongs to the better systems because we have a specific set of losses, R&D losses, that are designed for R&D environment. So we have some of them about the cadence, some of them about the first defect of engineers. So wishful thinking, they think their idea and the first idea is the right one. So they fix specifications or they never change their mind until they crash on the wall. And then there is also, okay, the problem of flow losses, and there are also not using the knowledge that was already in the company, and many others. So with this set of tools, we can do a nice work. So here, for example, we can optimize the activities. This is a true example where we see that they decided that the added value were those activities, but also necessary activities not totally adding value or not at all, were those activities that had to be done, but were not efficient. So for example, a 60-40 consumer test is good because it gives a way to screen a new idea, but this is also very time consuming. Competitor analysis is a lot of research, which is not only at the end is transformed, the 5% of the effort transformed in value. So, and those are totally waste, repeats and so on. This is a point of view anyway, which is not superior to that. It is just covering some of them because I remember there are losses in the activities and losses in the traffic. And this is why we usually do a double assessment on the system, on the traffic. And very often we find that 35 to 50% of projects, they have problems because of the failures in project management, because they were delayed, because they were not meeting market needs, or they were too late or too early. And on the other side, we have all the NVA in the tasks. This is exactly what I showed you before. And you see that 50% of added value is a good benchmark. We have a very strict definition of added value, which is reusable knowledge. But generating reusable knowledge for 50% is really a good achievement. And if we multiply the two, we could end up with a productivity of 25%, or very often it's 30, 40%, which is a perfect good news because in lean manufacturing, in manufacturing in general, we already are used to efficiency of 85, 90%. In R&D, not yet. So there is an incredible gold mine. And if this is strategic, come on, this is perfectly the opportunity to increase productivity. And increasing through lean and agile, a combination, because we could fall in the mistake of being fanatic only on one of the two. But in the end, the world is not waiting for our categories. We need both, and I'm going to show you in a while why. So we need speed and efficiency, and we need to achieve speed in an agile way. So we need to have fast feedbacks, short iteration, cross-functional teams. We don't have the time to wait for hierarchy, for meetings that happen every month. We need to have the information tomorrow and how it's going need to be transparent for everyone, and we need to be lean. We need to avoid waste and understand the value. We need to think about the value for the customer. So these are the potential. Wow, you say, are you sure? Yes, I'm sure, because this is a case we started in 2014. After some cases, we said, come on, this is a double-digit improvement. And those, so the blue points are the base we made in 2014 and the years before. And then this is a correlation because what we measure with the loss analysis and what we achieved, or was really easily achievable. And then when it is not achieved because there is some enemy in the organization, some organizational change, some business disruption, but this is proven many, many times. So we are talking about a double digit where 20–30% improvement is really achievable, at least. Good. So how to make it? If it is true, how to make it? And now I will show you what we usually use. We have the so-called paradigms, the Lean-Agile paradigms. On the left, we have traditional patterns. So maybe something that is already a good achievement for many companies, in the end becomes not an excellent approach. For example, we say we have top-down plans, and we have the board making, the giving milestones and the Gantt with the PMO. Yes, but this is how the Americans lost the Vietnam War, because they were not making plans. They didn't have the feedback on the field. So the combat planning was invented there. And then we are very proud. We maximize the load of our designer. Perfect way to fail. We need to minimize the queues. We need to have a freedom. We need to avoid to oversaturate our resources. So, but instead of going through the list in a very boring exercise, today I have a very special surprise because we will see them again through an example. The example is an article that I found 3 days ago on the New York Times, which is an incredible article. It was really the destiny. I found it, and it tells the story of how long will a vaccine really take for COVID-19, of course. And it is an interesting case, and the comments you are welcome at the end of this example, for example. But I will also give you some new hints about this approach. So we'll try to see if the 14 paradigms are able to support a time to market reduction for a vaccine. So first of all, target setting. Now, there are people that say that we can have a vaccine already tested in September, yeah, but then scaling up the production, we're reasonably, if we count from January, in August 2021, we should have really a worldwide distribution of this vaccine, if everything. And then you say, wow, 18 months is very long. Yes, but see, look at the others. So we come from performances of 28 years or 15 for the rotavirus, and for other illness we don't have one yet. Okay, so this is the target. It's really amazing jump. Is almost 7 times less. And in this article, which was made with experts, but I really credit this guy that made, okay, this is a typical time to market we can say expect if we put all the phases in a traditional way as the FDA wants, and many pharmaceutical companies do, because they don't want to risk too much. So we will end up into 2036. So I'm not sure I would even see this if the COVID stays around. Then he said we can go to August 2021, 91% saving. Now, before discussing, let's go step by step. So first of all, go back to the initial point and say, okay, what can we do? The first thing is we can say, but we have so many studies now available on coronavirus that we could start the trials early, because we rely from studying SARS and MERS already, and also the data we already have in these months. So why should we wait for starting trials? Preclinical, we already know a lot, and they are very similar. And then another thing is, why should we wait for academic research? Because we already, for the same reason, we know something. So we trust that we are in the good direction. And this is bringing us 4 years earlier. And what is the paradigm we have used? I would just give you a hint. So let's look at around 11 and 12, especially 12, reuse of technical guidelines. And also trusting that people will tell problems very fast if they find something. So there'll be a collaboration about the community. So number 12 in this case is at the base of that. We can do this because the knowledge we already accumulated can be reused, and then we can assume that the same conclusions are valid for this. Then, okay, 2032 is too far anyway. So let's do something more. Let's talk about trials. Trials, okay, let's try to speed the trials. You see the difference we start the following set of trials before the end of the previous one, because we share information, we see what is working. How can we make this? That's the first reflection. This is a very good way that also Toyota uses to shorten. It's a totally different approach. This is a typical stage and gate with design reviews at the end. And the second thing is, why the move to phase 3 trials by combining phases and go to large scale tests sooner? Because we can increase the number of people to be tested. We have tons of volunteers. And then even we can use emergency provision, so vaccinate frontline and essential workers early, so we can really speed up the approval later on and have an emergency vaccine by this. So what did we use for this? We used an interesting paradigm, number 4, technical build reviews. Because we are able to validate and launch the subsequent phases as soon as we learn something is communicated. And then there is a loops and rolling plans, means and visible planning, because people collaborating to that, they will know and they will collaborating in parallel. And the parallel brings me to number 11, set-based loops. We have more than 70 institutions that are looking for the vaccine. If we put together the efforts, the number of information generated in those months is by far more than the closed innovation model of one of the big pharma. So you see that this is possible if we apply some paradigms. And in fact, you see, this is an example of the vaccines that are under study. And some of them use some technology, some of them reuse old technologies, some of them use a new one. For example, this one is even easier to manufacture. So you see that those are potentially the set-based loops we need, concurrent engineering. And of course, they will become at a certain moment competitors, and few of them will be winners, 2 or 3, they say, but at least you have the opportunity to bring, and even a failure is good. About failure, why do I say that? Because statistically, only 10% of drug trials are approved. So if we don't have this, there is no way to make it. by the time we set. And then what about manufacturing? So building factories, traditionally after the phases, we have all the specs and we start building factories. But then my point of view, I make, in the teams I participated, I followed 15 big projects, greenfields or brownfields, and I always say, but there are so common patterns. So why do we wait building factories when there will be a vial to be filled in, and there will be walls anyway, so we can start making things in parallel. In fact, in the article, they say, okay, we can build factory and manufacture concurrently. What does it mean? That we need to be really agile. We need to break down the building and understand what is really the key bottleneck and the key decisions, and then make it possible to change. And even there is an interesting idea. If we use this vaccine, the manufacturer will be much faster because the smaller doses. But that's a long. I'm not expert enough, and there is no time. But it's very, very interesting. You can see. Be careful about the volume. Somebody is. Okay. And it's interesting what you see. Why Bill Gates said he will build 7 different factories for the 7 different vaccines, because that is also one way. Because if there is really such a difference, and there are 7 families of vaccines, what is the thought? So in the end, he's making more money than me, but for sure. So he's wasting a lot of money. But if we find the good one, which is the payback, so some billion doses per year for many years. So it is even interesting to invest in set-based design. That's a way to do the set-based design, isn't it? So let's check if we find. So this is, in the end, technical build reviews. Try to understand from the trials what are the guidelines for manufacturing before it's too late. And then having loops and rolling plans to give the specification, but also set-based again, maybe building parallel different solutions, and then go for the last one. But then I would also say reuse of technical guidelines. If you can postpone, this is also key decision at the latest responsible moment. Start to build the walls or the factory or some processes that are probably already in a certain range, and then keep the last one for the specific characteristics. So late decisions can help sometimes. And you don't need to wait for all the decisions, just for some of them. So that's another way. And then there is another thing, is very simple, but regulatory approvals to take 1 year, and they might take technically 6 months. It might take 6 months, which is, in the past, has been a disaster. So I don't know if you remind that the polio vaccine was so urgent that it was delivered in the 60s, last century anyway, too fast, and there were effects on people. And this is probably the root of anti-vaccine movements. So we need to be careful. We need to evaluate if this is possible. Anyway, with a priority, with this as a fire truck for once, could go through the FDA in 6 months. So emergency vaccine by February and distribution by August. This is the conclusion of the article. I don't know what you think. For sure, that's a really fantastic job, but I don't like this. I'm not satisfied with that. I love this, sorry. I cannot stay with this because there are some questions. What about if something goes wrong in the phase 1 trials, for example? Are we protected from risk? What about design loops? Do we have space? Because this is maybe a big bet for having a perfect right first time sequence, which is not the case in the average project. Maybe in this project we put the brightest minds and will be. But for us, this is not the model. The model is also to have a certain really interesting thing, which is the insurance given by the buffering. So keep the system under the tipping point and deliver a portfolio of projects. Don't deliver just one. We need to deliver all our projects in the portfolio. If we have put in the portfolio, if that decision was good, every project deserves to be launched in the market. And the tipping point in this case is our resources, critical resource. That is, Goldratt says that's the critical chain. So once said that, we need to understand what does it mean? What would we do? So how many assumptions are we making on infection rate? So will it be the same mutation? Will the virus be the same? So we're testing something that will change. Immunity achievement, really with the virus, will it work? Reaction to the vaccine, climate effects, organizations to do all those, queues for approval, collaboration of research entities. When we will be in this area, in this phase, will the institution will collaborate or not? They will start trying to hunt for themselves. And is this plan resilient to risk? Of course, I don't know, and I really thank the author for this, but let's assume that I don't know enough. So we need to think about this and apply anyway the critical chain, because what we don't have, at least is not visible, is something that is the real. If the initial date is here, this promised date is here, the reality will be in the middle somewhere. And we need to calculate where. There is a way, which was invented by Goldratt. The author of The Goal wrote a second book on the critical chain, which is a beautiful book you should read. I really summarized the book in 3 pages. The first idea, it says, okay, you have a project with 5 activities. Which is the probability that this project will be on time? And maybe you guess, you could suggest something in the chat, but I tell you, probably you don't imagine it could be very, very low. So less than 50 and maybe around 30%. The reason is in this, that every activity, when you plan, is usually planned when you have an important project, some optimism and pragmatism. So you put, okay, the duration I will put is the one that is covering 75% of times. And then sometimes there is a problem, but okay, it's too long. So this is maybe the plan, and which is a total reasonable plan if we see one by one. But the overall effect, combined effect of those is that only if this is 75%, multiply 75%, multiply 75 and so on, the probability to be on time is 23%, 24, 23. Wow. So why don't we take a bit more of margin? Let's add some extra pads in the activities so we can cover 85%. So we had to tell our boss we need to move 10% the deadline, and we double the probability to be on time. We are still less than 50%. If we want to be more than 70%, we need to have something like here, which is not acceptable. So that's not the strategy. And even when you have those pads, you lose them, because when you have time, like students, you study at the end, you do a reverse planning, you study at the last night, the last week. When you have multitasking, you cannot respect aggressive sequences. When you finish early, the successor doesn't start because there is a plan written in the agenda in Outlook. So why should I start if there is not a system to make it flow. And then there is a Parkinson law, the work expands to fill the time available. And then there is progress management. If you are rewarded by progress, and this is the critical path, maybe you do a bit of this, a bit of that, you feel happy, but you don't understand that you should progress on the critical path first. So there are a lot of mechanisms that destroy the wise project management. So we need a better system. The better system means to design another way to protect from delays, which is this, which is like in supply chain, the safety stock is in one place. We need to have the safety stock of time in one place. So we take all the, let's say, aggressive but achievable duration, which correspond to 50, 60% of the cases, or something that you reason when everything is good, it takes this amount of time because the decisions are good, there is no interference, and there are no organizational losses. So this is the duration, and this is the shortest Gantt. So this is a kamikaze plan, because if you promise this date, the probability is maybe 50 times 50 times 50 times 50, so very, very low. But if you take then the paths, and then you consider that only 50% of that is needed because the probability that you need all of them is very low. So you can put half of that here. You have a plan which is very aggressive here. You pull, so that's a pull, that's an agile and lean. You pull the plan, and then you have an insurance. How does it work? It works that if in the project like this, you have a problem in the first activity, the whole project will sleep. Here, the same, because that's the mathematical. But we have the same delay, but for a shorter activity, and all the rest that we sleep is a shorter chain, and we are using our buffer. So we don't, here we are late, here we are not late. You see? Please mute, there's somebody writing on the keypad, and I can hear it. Okay, so you see, this is an incredible tool. And then if we keep this visibility on the buffer and we keep the people, we pull them to be aggressive and to start as early as possible, like in a relay race. If you are late, you have early, your companion starts early, doesn't wait. Oh, no, in my fraction, it is from 20 seconds on. You take the advantage. So those tools I will explain you in a while, with those Kanbans and Scrum that you probably know from Lean, and capacity model you know from any planning system, SNOP, for example. You can run this system. And how? Yes, because now we have a new playground. The playground is the fever chart. So we see how much of the critical path is consumed and how much of the buffer has been consumed. So if you are progressing with a small and less than proportional slip, is fine. If you start eating up the buffer more than proportionally, you end up in the red zone. So even in the early phases, you are not optimistic like many of our, because we know, we have buffers in the other activities, we will recover. No, we are eating too much. The trend is not good, we can react. And this, in fact, what you can see here, where you have 3 projects. This one has a trajectory that is worrying. This one is very good, and this has been corrected. So you see that there is a new way to monitor projects and to follow your portfolio. So coming back to this, if we could calculate and add a buffer there, we could say by the end of the year, by the mid of 2022, this is the probability to have a vaccine is for sure is much, much higher. But maybe that, as it seems, it is even possible to have it early. So now we have seen some of the examples. So this example was really lovely. Now we see that there are other examples of paradigms. I want to show you this, for example. Paradigm number 2 is from managing delays to managing achievable scope. So you cannot do this with a vaccine because you need a vaccine that covers completely and treats. But for the iPhone, for example, works very well. So in some cases, you are not late for the market, but you just give some features, and then you test some of them, and then the good ones are kept, and you add on the following models, one after the other. And then you are sure you're following the value of the customer, because you're not thinking all by yourself the perfect iPhone. You're just watching what the customer are using, which is great. And then this is absolutely being able to smooth the project profile, is avoiding peaks and valleys, which is always a problem, because poor productivity here, people will expand with the Parkinson law. Here, the people will get crazy because they are overwhelmed by work. So you need to have a scheme of projects which are like these, guaranteeing a smooth profile. That means to plan the projects and the cadence of the go-to-market, including the workload definition or hiring people when needed. And this is another nice, even though we have proofs that not all the Tesla are really totally infrangible, but this is a very good example of fact-based design reviews. Design reviews are very often a meeting where an expert that doesn't know a lot about the project needs and asks you a lot of things, and they are nightmare meetings. But the real design review should be like this. And this is a test of alternative solutions with the different tiles for the roof for the Tesla. And you can see with compared results, which is the best. That's a review that takes a design effort, but then just a few to understand. And you can understand which is the material, and you can do loops about on that of design engineering. So another one I love to explain is this. I've seen many companies spending ages and millions on the process. It is like, let's say, cleaning the car perfectly and having an engine of a Ferrari. But if you are in the traffic, there is nothing to do. So, but also sometimes drivers doing many things that crash because they don't interact properly with the others. And if you believe me, more than 40–50% of the time elapsed in a project is waiting. So iterations and interactions are really important. We need to do the right thing in a very agile way. And for example, what does it mean? That instead of having the old approach of the phases that are sequential, which is not wrong at all, but this is not really interesting. What is interesting is what are the key critical points in a project. Let's imagine a feasibility loop for each of them. So maybe even 3 of them, very aggressive, very agile, very fast, but try to find with the functional analysis what is the product critical feature that need to be tested first, so that at the end the product loop will be very fast. So we need to plan. So we need a way to put flexibility in our planning. Without that, our planning will be always disconnected from the reality. And the last of the example I'm showing you, no, there is another one, is this. Instead of worrying about saturation of resources, you should eliminate the queues. When you launch something, you should have no red lights. Go. Eliminate the queue, so people will get used to receive something and deliver it the day after. And there are many, many others, but maybe we can come back. Set-based design, we talked before about Bill Gates and the 7 factories. One that invented the set-based concurrent engineering was one of the Wright brothers. They were not engineers, by the way, so they didn't trust what they thought. They just tried to learn. So they tested. This is what I found in Washington, at the Smithsonian Museum, and I found that they tested, they recorded data on many of those wing shapes with a very archaical wind tunnel, and they tried. They didn't know how to fly something, so they tried to see and to learn from trials, and they were planning in a smooth way. And this is exactly what we should do instead of thinking that we are right or doing useless tests. So another thing I want to share, and this is the last on the paradigms, is this. We don't imagine what can be the power of exploiting the knowledge in the community. Nowadays, we have big data, machine learning. Yeah, okay, machine learning is exactly what we should have been doing in the past with human, because machine learning will be a great help, but there is a lot of things in development, especially, that without a designer or an architect or an engineer or a chemist will never happen, because the machine will not imagine that. And knowledge is really the gold. In fact, the value adding is doing reusable knowledge. If there is no learning in the organization, we fail or we succeed, there is no feedback, no lesson learned, and no reward, nothing. So we have an organization with a knowledge of 1, at the end of the year, the knowledge is still 1. If the organization is able to choose every week a subject to capitalize, at the end of the year, 52 weeks, there will be 1.67, even almost double knowledge in the team, if they listen. If they learn every day, it would be 40 times, which is maybe in Google, in some very, very brilliant companies or small startups or special companies, it might be, because this is what is needed when you are really innovative. But let's stay on the earth, and this is an incredible achievement. And every time you learn something, the next decision or the next project is faster, because you have, for example, process parameters. You master them, you know why there is a limit, you know what happens, you know the capability, you know which product is likely going to respect it or not. So knowledge is gives you a lot of money, and they will be translated in higher yields, better quality, less control, design for manufacturing, and so on. Okay, so now we are flying to section number 4. Section number 4 is showing how to keep the flow running. So, for example, this is a case of a company making bread and savories, and that's the pipeline, and we see which product is at which stage. But for example, and then we can make a projection of the sales by segment, by product family. But we don't know if we can make it. Is the capacity of resources able to cope with that? Or it is just a marketing exercise? And then how can we control the speed? So if when this product has to go here and here, and is it going to the right speed? Yes or no? So this is just a snapshot. And then are we learning from this in order to reapply this here? So to increase the speed. You see that there are a lot of things. So this is why we need to use a better system. The system is that know us, we are really fanatic of this in production, but in supply chain, and of course in R&D. There are 2 loops connected. So this is why you can do infinite number of times this journey. You are not obliged to do every time like this. You can have a lot of control loops where you have your KPIs you want to sell, then you have all the alignment of teams. You decide actions, and then you review results, and then you control. When you're not satisfied, you have a good idea, and the KPIs are showing you could improve benchmarking, you could do faster time to market, or we need higher productivity. Okay, we can do the other loop of improvement, and maybe analyzing where we are losing time, and then putting up some teams to analyze and creating better standards. And this is the system we offer. We offer all the time a very simple one, digital, where there is nothing to write. Because if you have 40 projects of 100 activities, or 2 projects of 2,000 activities each, then the typical work of the project management is hunting people to know, did you do this? Did you do the progress? How it is? Which is the problem? And you spend the time and the money to follow information that is already available. Instead, you need to put on the top of everything the digital process, which is running by itself. And then you need to put your intelligence here and your collaboration here and the human dynamics here in order to understand what is going on. For example, the first thing we need to do is a smart project. It is like the car. We need to have a good car. We need to have a car which, for example, has the characteristics to be flexible in the traffic. So we need project templates that not only they consider the workload per function, and then the protection from risk, we see the critical chain, and then we need to do the capacity model. So we need to know which is the effort, and many people do this, but don't use it in the right way. By the way, you need to have templates that are really fitting the project. I'll show you an example. Project configurator. Typically, we have project templates, and then we have, okay, case number 1, color change. This is we make eyewear. This is a simple project. New concept, that's a complex project. So we do, if we have one standard, it is too heavy for this and not enough for this. So we have 2 standards. Okay, let's take 2 standards or 3 standards. But then there is a number of things that could happen where every activity has its degree of complexity. And we should go through this driver, not by project, but by activity complexity. But if we go by this, we could create too many project templates. And when you change something, you need to maintain. And so we need to have a configurable standard. For example, in this case, we have the raw materials that are complex, of course, not easy to find or to cut even. And the design is nothing special. So we just need to connect the jewels with the frame. And the process instead is really complex. In this case, the raw materials are very simple and standardized. The structural design is simple. The process is complex. So what do we do? Is this a simple or a medium? Now, in reality, the answer is that we need to have a full template with all activities, and then, depending on each project, covering the right scope, size it according to the risk of each activity, and so we have the project plan. The example is this. For this, the procurement is simple. Okay, let's put it into the Gantt. Product design is more complex. Okay, let's put it here. The packaging design of this is medium because it's similar to as an overall size to another one. Process design is medium, and product validation is simple. So that's the Gantt chart, and that's the shorter list time we can have. What we have done, we have put together parts of a library of modules and solutions. So in reality, the solution that we're looking for is a solution where with one project standard, we can create, paradoxically, an infinite number of situations, and we can also insert trials inside. If there is a high risk, we will add routines. It's a modular thing. So this is really something we can do and for you to test and applying the critical chain. And the second step, once we have those, we can populate all the projects. So this is a number of projects we might have, and we put in one file. Putting in one file means that we have an incredible database, which is a treasure for advanced analytics and even artificial intelligence. Because if we know the progress of all projects simultaneously, some activities that are delayed, wow, that's a great information for another loop of improvement. But nevertheless, this base at the moment is very useful because we can use it when we meet. When we meet in the Obeya room, the representative of functions will meet. So this will be a digital room nowadays with all the information, people sitting at home or sitting everywhere they are, but they need to know what is the workload that is coming in the next weeks, which are the hours. So are we resource by resource, group by group? If we put together all the standards, nobody's writing anything, but then we are creating this automatically. And then, which is the performance of industrial engineering? Wow, this is the input of all the activities in the last weeks, and this is the output. So the lead time is 2 weeks, fine, which is in line with the average standard. And what happened in the last period? Vacation, problems, blockages. So that's an answer we need to have. This is why we meet, because if everything is smooth, we don't need to meet. And we need to take the decision together. One of the hardest decisions is this. We need to have one fever chart with all the projects and discuss about the strategy for having all those projects delivered. So what does it mean that we have projects, 3, 1, that 5 don't need any comment? We need to talk about project 2. What do we do? Maybe we give a priority to the lab to project 2, and we delayed a project 3, so we will not eat up all the buffer, but then we will progress here, and they will go together to the end. So you see, and also there is, of course, a logic in this. That's an example. I anticipate a case study, which is a medical technology example with 250 people, and we put in place routines. So the procedures, the boards, what do we want in the Obeya, the KPIs we wanted, and then the cascading, because we cannot talk with the CEO about the project number 4 if we miss a mold, but we need to talk about the mold. So there is a meeting on the Monday, that's the day of meetings, a local team on the floor, which is engineering floor management. We just clear all the problems and we do an action plan. We check all the progress. When there is something to escalate, we might go to the department of industrialization, of development, of testing, and then we might go to the area where we need to talk about the portfolio. So in the morning we have a situation, and then in the evening we have the decisions that will be cascaded. So there is a logic, and it is exactly a logic for that we use in manufacturing, but with the new tools and with new information. We cannot talk. I've been in so many boring meetings, you cannot imagine, where the detail were killing me and there was no decision. The nice thing is that if we have all the digital process, everyone, so this is development, receives an Excel file with all the things to do in the next weeks, and also the late tasks. You see the late tasks, and also you see the workload. So people can prevent problems, can say, hey, I have a problem in week 39, but I have a space in week 38. Can we anticipate something? Because that's a pull system, it's not a push. And if there is a problem, everyone is there and they can decide, okay, this task will be postponed. And what can we substitute? Because we don't have, for example, a supplier. And this decision is instantaneous, and we don't need to make many other meetings. So the meetings we have seen are substituting a number of meetings and emails that you might incur. And this is honestly is a saving of 2 to 1. And then at the end of the meeting, there is a new plan. The new plan is creating the Scrum. So you see that the Scrum is also a very autonomous, but you can, which is meaningful in software design, is meaningful in some cases, is beautiful. It also can live, Agile can live with Waterfall. Depends at which level we play. So Waterfall is good at high-level planning. We have milestones, we have big phases. And also at the low level, we need to have Scrum, where people decide in the team what to do first, when, and they can help each other, CQ department, different people can do this. Alessandra, Giada, Stefania, they do things, and they can decide the best strategy to be done at the end of the week. And the nice thing is, once they put it done, this is fed back into the project. So nobody has to write emails, say anything. It is just doing each week what you need. So with Excel, but because that's the common technology, but then we have a Solvay for our solution, but you can have also SAP systems or Planisware, Primavera. So there are a lot of solutions. None of them has all those things I'm showing you, but this is a way to try and then to take your decision. All this is done with the eye to the technical axis, but then an eye to the human dynamics, because everything that you introduce has to be adopted by the team. And you need to coach them. You need to anchor the behaviors, because if people come to the meeting and they don't have an answer, you just lost another half an hour. So they need to be prepared, and the representative of the function is not prepared of what the team has done and why there is a problem. Which decision can you take? So you see that behaviors are, at the end, the most important thing. The system is not so difficult. It is more the matter of leadership and behaviors. This is a case. Now I can leave you some space for questions before we go to the case studies. So I can choose, but nevertheless, this is already one example. You see that by applying the Scrum and the things that I showed you, this is a real case of a small multinational company. They are ahead of Bayer, for example, in innovating solutions, innovative solutions for special glues or foams. And when they are disrupted by Bayer on the economy of scale, they have already a new generation with better performances. But not only, it took at the beginning 15 months on average, and then, 9 on average, and then they went down to 1.7 in 2 years. So this is why the infinite loop has to be is a journey that should be repeated many times. It's not an instantaneous solution, but it's absolutely interesting to see how much we can save. So we are not far from the improvement we have seen in the vaccine, isn't it? So it is possible. But then we need the whole organization aligned. And then this speed didn't mean less on time, because when people understand that when you have a task, that's a priority, you all belong to the project team, even though you just do master data, and you don't do your sequence, your own agenda is in background of the project, then everything is done until we guarantee that the workload is not overwhelming. You see? So we need to switch from an overload because lack of trust to less load and reliability. This is the secret of Lean-Agile. So you can monitor, and then also you can use statistical analysis, artificial intelligence with all the projects here, see the deviations, see the reasons. In the Scrum, you can write why you have the deviation, so you have the time report for free, you have the loss analysis for free. You can have an analysis of which project, which activities, in which situation is likely to be more delayed, so we can improve the standards. So that's a gold mine. So if you want to ask something before I go to the case study, you can. So I see some questions. Thank you. So how is the Lean-Agile approach integrated in our APM approach? Good point. So the early product APM, for those that the customer that maybe don't know, is a APM approach, and early management is perfectly. In fact, in EM, in the last project with some of you in England, we are using Lean-Agile inside a big engineering project. Because we are making sprints of activities, we highlight which are the key decisions in the next 3 months, and we organize sprints to take those decisions and have them validated. So the APM EM is the overall umbrella, and Lean-Agile is the way we use the work process and the reporting and the meetings inside. So they are perfectly compatible. How long does it take to implement? That's another question. Who needs to be involved at the very beginning? Okay, very good question too. It takes, you have seen 2 years. So to implement this, now we are making the record in this situation in 2 months. This morning, before this meeting, I was in another one. We finished the training and the development of the system. We launch next week on a virtual basis. So we were able to do in 2 months this system, exactly this one, because examples are taken also for that customer, in 2 months to set up this. I think they were really good customer, understood immediately. The first person in 2 months, and then it will start working from next week without having those fantastic results. Results will come in, say, 6 months. Or even less, I say. Those are really, really good. But the first person I talked to was the owner of development in terms of business, so the marketing in this case. And the second was the CEO. If they don't understand this, the value of this, the limit to the portfolio, and they don't understand the limit to overall to the overload. In Philip Morris, for example, we decided the rule of the 3 special projects per month. You want another one, you take out one of the 3 that are already in the pipeline. Sorry, we don't manage 4 fast tracks per month. That decision was a bit difficult the first month, and then you can see the results later on. We tripled the productivity. So if the management doesn't believe in buffer, they don't believe in meetings, already top management, there is no way. In fact, the cases where we didn't achieve the results were all due to this problem. Then we need to have the cascading down, and it is a coaching and a lot of work on people. So 2 months to develop it, 3-4 months to warm up, to ramp up with coaching, and then improving. If there are no organizational losses, let's say. And then yes, of course, we have another question, typical workshop to involve the top manager, other people, we have games. We have more and more examples. And also we simplified the tools in order to be, with Excel, we can do everything you want to try. It is the old Post-it. Excel is the old Post-it. Now you cannot have Post-it because it's unmanageable, but you can have Excel. Then you can upgrade to another system, the one that is fitting, that is your strategy of digitization and everything. Okay, what else? I can show, so thank you for the question so far. I hope I answered. I can go to case studies. We have, so the medical devices were the engineering floor management. And let's go to this, eyewear. So this is a page I'm very proud of, because you know that the intro to professional always present this case. This is a case of a small, now it is not small anymore, it is the third player in eyewear market. They have big brands. Now they are doing they are running a joint venture with Louis Vuitton and LVMH. And we built the factory with them. We did a very agile process, but specifically, we started working in industrialization, because you can imagine if you need to do, 2,000 articles per year with 333 models, and in development, in industrialization, with you have 0.6 months per model. You have 100 people working on that, with 4 months per collection. And so you have 80 collection per year of those guys. They love winter and summer at least, if not special collections. So you have 27 collection on average in work in progress. How can you apply the paradigm of low work in progress? You need to distribute the work very efficiently to be sure that people run. So this is what we built standard templates. Then we went from standard to customized, and then we went from duration based to workload based. So with finished capacity and visual management. And in fact, we understood that instead of having each release with a late big amount, we try to smooth the amount of models, try to anticipate some key decisions, technologies, material, colors, where the feasibility things that we anticipated, and then we could release faster and earlier. That meant we can smooth the workload. And the workload was terrible, because it was peaks and valleys were of a ratio of 4:1. So you see, with those things, we had a program. Overall, we had a synchronization of product development, industrialization, and then launch. And this is the left loop of the infinite loop, the control loop. With the yearly plan, you see standards configurator, the Kanban that you saw, the capacity that you saw, the Scrum that you saw, loss analysis, and then the check. So this system was implemented and brought to 20% productivity. And then we also digitalized that, because nowadays they integrated with the SAP, for example. So one designer can, for example, declare an activity done, even if he's traveling somewhere, visiting a customer, but has approved a model. And this is a very smooth process. Cosmetics. Oh, this is a great result in this multinational. We really needed to help them, because they went from 4 to 6 collection per year. And 6 collection per year means that if you overlap 6 collection, whose duration is 1 year development, you increase the workload and the work in progress at the same time. And if you increase the workload, the time increases. So you need to launch a collection before the week of fashion is done. So you need to bet on next year fashion with your collection, because you cannot develop in a shortened time before you see what Armani or Gucci is proposing, and you're making maybe the colors of the season. So that was a potential disaster. But what we did with them, we worked first of all in 2 dimensions, on the flow of the projects and on the organization and the condition of each function. So we worked in order to eliminate losses from the plans. We went with them to study ways to reduce risk and anticipate risks. And then we also worked with R&D, lab, industrialization, regulatory affair, quality. So a lot of functions, they were involved in Scrum. The work standards were made very agile. So the Scrum system went, in this case, you can see with the post-it in some places, it was some years ago. And then we introduced the fever chart. The top management, they have 1,800 projects per year, and they talk only about the fever chart. They don't discuss, my project has to have as a priority. They just try to solve problems with the reds and bring the whole portfolio to the end. So the results was with a better project team, a program manager role was introduced to orchestrate everything. With all those systems, many of them, I explained, not a functional analysis, but there was no time. We reduced 30 to 50%. And that was enough to increase productivity, to avoid, to overlap, to reduce the time to market, and to launch the collection later. So when you have the information, so doubling the effectiveness and reducing the waste of material at the end of the collection. Then there is another case, the case I mentioned before, fast-moving consumer goods. So in this case, this was really, it was 10 years ago, more or less, or 9, 10 years ago. Instead, in fact, this project won, that's Philip Morris, so they awarded this small team in Italy. They wanted to close the unit, and they decided to keep it because we achieved this incredible result. You see that from 100 to 391 with the same team. And the reason was that there was no visibility on what was coming. There was no configuration of projects. So all the filters for cigarettes that were the case were treated in the same way. There was no synchronization of resources. We put a program manager with a project, with a multi-project, to understand how to use the resources better. There was no stability on project list. There was a freezing period monthly. Okay, we don't change and we don't accept more than the famous 3 special projects. And then each project had a follow-up, and each project was in the room of development and installation. There was a magnetic room, and then became an electronic Kanban room, Scrum room board, sorry, where we twice per day the people were reporting what they had done versus what was planned. The tracking was by 2 hours, units of 2 hours. It was an incredible effort at the beginning, but then was giving these results. So with 1 resource added, the program manager. And so to give you the idea, but in fact, if the numbers I gave you at the beginning are true, this is possible, because if you start with a system that has an efficiency of 30%, doubling or tripling is not impossible. Another example in food, this is, just to show that there is no industry where you cannot apply it. In this, you have a calendar with all Easter, fall, winter, specialty, non-seasonal. So there are milestones, and the process is divided in steps. So there is there is a standard divided in small steps, and small steps are distributed across the calendar. And this is more or less the image of the prototypes, approval, feasibility, theoretical and practical, and then relaunch of industrialization. And this is more or less the overall flow, which you can find in the different dates. And now Easter has gone, but there is a risk analysis, functional analysis, because you need to study the product. Can you handle it? Can you make it a dimension? Can you transport it? You need to have the size of the of all the components equally distributed and or not. And then we decided how many loops we needed to do. You recognize Lindor. And this is the capacity model too. What we did, not only we understood how much should be the work content of each project, but then how much all the projects together mean for those teams, which is marketing for Easter. This is purchasing, R&D, development, engineering. Okay, you see that there are peaks, and in this situation, R&D has a peak here, purchasing has a peak there in January, and in March you have another peak. So you can smoothen a bit by planning and trying to distribute projects. If you don't have those numbers, you cannot do that, and you blame, you don't trust, so you tend to do projects earlier because you don't trust the duration. If you do projects earlier, you overload your resources, and then you get exactly the opposite. So the capacity model was refined, and then we got a better one. And also we invented a project configurator with some decision tree, so we could generate automatically a Gantt chart on Microsoft project based on some questions on and off we had in the project, based on some logic. So that was really an enabler of a better planning. And then the same plan and control cycle. And now I'm ready for your questions. Okay, how many people are in this Scrum team? Good point. That's a design parameter. This is really depends on the organization. If we have many projects going through a department, the Scrum team is the department. Quality control gets the activities that can be even personal, so you can have sub-teams inside, and the number of people inside is not really the problem, should not be too high, should be homogeneous work and homogeneous business. So those activities should be really belonging to a similar, let's say, group. And this Scrum team is not working as a classic Scrum team because the intelligence is in the project standard. So the next activities are already contained in the project standard. When instead you have let's say, a big project where there is a big task of many weeks and you need to organize your Scrum team, this could be a totally different situation where you have maybe, like in a new car, you need to study the new seat, or in a big new machine, you need to study the loading system. That could be a Scrum team for a number of weeks. And anyway, I would suggest not to go more than 10. 5 to 10 is my answer. Yeah, the main issues we can face in this, the main issue we can face is we have a weak component in the team, because there is a moment in the Obeya room which works very well, which is the public, let's say, exposure to your commitments. And if you show up being late every week without saying anything, you become really the worst of the team. But if you don't care, that's a problem. You might be really in trouble, because we need to have the adoption. So the real problem is the adoption of everyone, because it's sufficient one element which is not collaborating that the flow is slowed down. Of course, typically, if the ambassadors and the important actors in the process use it, like in Yves Rocher, there was one obstacle, and that said, but I'm not really doing projects. I'm just doing a regulatory affair. And I was answering in my, say, kind way, and the responsible of the lady, the responsible of development, jumped standing and say, you don't know, you didn't understand after all those years, you just do projects. The thing is, you just don't care because you do in your sequence by your own agenda. But if you gave us regulatory answers in phased with our projects, we would go much faster. This is what happened. So we need to work with the ambassadors, with the guiding team, and then the rest will come. Another question is this following the Scrum and Agile methods or an EFESO made? So in fact, I used, for example, in ST Microelectronics, the full Agile system, and I say that's a unique blend because this is the strongest. I experienced a full Agile, and it lacks of frame. I experienced the full Gantt or top-down planning. It is horrible. This blend is really effective and respects the principles of Agile totally, the principle of lean development totally. The only thing is everything is used in the critical chain. No? We use everything in the best, let's say, field of application, which is in the end why EFESO is #1 in the world for a pure player in operational excellence. We are not saying, for example, you experience that in production with the lean manufacturing, and then Six Sigma, then Lean Six Sigma, and then you always find that some losses are outside or some tools are not good. So the reality is that if you put in a harmonized system all those tools, the reality is not listening to our categorization of tool or our fanatism. The reality is we have projects and we have a business, so we need to answer to that. And this is, in my opinion, an evolution of unique so far of what you can find in the market in the standard tools. Other question, for example, what is next? So the next challenge is to do the same thing, but in an open innovation business model. Because new revenues can come, and if you notice in the reshape module, we were talking about rethinking the value chain. So we might develop something that can be built somewhere else. Or to develop something, we need another technology that we don't have. So we need to collaborate with someone else without fearing that they will steal it from us, because time is more important than secrets if we find the right partners. So in an open innovation business model, we need to understand what are our capabilities in development, and to be complemented with our capabilities of development and distributing and branding and production, and put them together. But in this scenario, don't you think that this is a necessary foundation? Can you imagine to collaborate in an ecosystem without Lean-Agile, without synchronized things? I don't know if you experienced to work in European projects. I did many of them. And it is really frustrating when you find work packages delayed and you don't communicate, if not every 3 months. It is really a problem. And this is like a prototype of this new open innovation. So open innovation means to be able to collaborate with suppliers or partners in developing a new idea. And nowadays in the smart cities, for example, the number of technologies that should be ready to enable your service to be delivered is huge. So it is not just 2 or 3, it is maybe 10. And it happened to me that we organized a very big meeting with the company, with the market people, with the potential supplier, R&D, pure research, marketing, and business. And we found very nice ideas. So design thinking was was the backbone of this. But then we found that there was no synchronization and no capacity to develop things in less than 3 years. So you understand, we need, if we want to react, we need to have flexibility and agility also in the organization. So this mantra is a fundament for the next level, which is that. Can the approach be cascaded in a team located internationally, working in a complex product like aerospace industry? Of course, yes. Of course, yes. If you see that aerospace is fragmented for political reasons, it doesn't make sense on a value chain point of view, but makes a lot of sense for technological point of view sometimes, and for political point of view, because people pay, the nations pay billions, so they want to get something in exchange. So this is exactly what is already happening in some teams. In fact, if you think about Pro Engineering or CATIA systems, so Dassault system, the data and the files of design files and informations are exchanged digitally. What is also very interesting is that these systems should be implemented thoroughly, because in the future, in the next month, for example, not traveling, you cannot have easily a meeting face-to-face with international R&D and industrialization. And how can you do early management if you don't meet production people and maintenance people that should build the factory where your new airplane will be made? So you absolutely need exactly this. And the agility, the agile is very good, because you don't need to make a super precise plan. You just need to be super precise in identifying the next key decisions, and be reactive and responsible in seeing the results and planning the next cycle. So keeping this chain that you see on the screen aligned and synchronized in the next month, with driven by a program which is years, where a lot of money is involved, but you don't need to have a perfect monster planning. In complex problems, system engineering is often used with a V cycle. This approach is a challenge to these organizations. The experts in model-based system engineering are introducing sprints now. Yes, I participated to some of those. So, for example, a new packaging, for a multinational, that implies a new machine with a new production line with new features of sterility, for example, for the liquid inside. I cannot, of course, probably I cannot tell you all the projects and the secrets that I know, which would clarify much better the example. But keeping it simple and generic, what we did, instead of going to the V cycle, which is too slow, going a lot down and then coming up, this is not false, but is not enough agile, because if you need to loop in the V model, it is a long loop. So what we did, we took again, we came after the team was started, and we started from the beginning, say, okay, reset. How many specifications you have? We have 300 specs. How many of them are must-have, and how many of them are should-have, and how many of them, okay, are easy, already achieved? And we classified them. And then we said, okay, how many of them are touching interfaces of the product, the process, and the machine, and the line? How many of them? And then we understood, with the help of a nice tool that is called the Design Structure Matrix, that is an advanced tool of this, we found the network of decisions and the sequence of important decisions to take in the next weeks. And then we made the sprints to solve those things in a sequence. And that was the key, because we unblocked, we avoided to rework. Maybe teams were worked in parallel, which is right. But then when they had to integrate the results, the risk was to redo completely the systems. And then instead with that, we had people working on interfaces from the first moment, trying to understand, okay, let me, okay, for example, the pump to sterilize the environment of the machine had to have certain performance, and he was interested just in the top and bottom, but especially the top rate of this pump, power of this pump, and the rate of the flow, because with this the design could take some direction. Without knowing that, the design could have been destroyed. So you understand that the sprints are absolutely the new way to do the same thing in a much smarter way. So I thank you very much for your patient participation and your good questions.